Topic 2: Equations, Inequalities, and Absolute Values. In this video, we will learn three types of expression, which is indices, surd, and logarithm. Okay, the first one is indices. Okay, indices for all a in real number and n in a positive integer. When a is multiplied by itself, okay, n times, that's that's what we call an a to the power of n. So if a is multiplied by itself n times, that is equivalent to the a to the power of n, where a is what we call as a base for the exponent, and n is what we call an exponent, or sometimes we call it power or index, where and a to the power of n is what we call an exponent as exponent expression. For example, let's say we have 5 times 5 times 5 times 5 times 5. As we can see, 5 is multiplied to itself 5 times, so this is equivalent to 5 to the power of 5. Okay, b, we have half multiplied by half multiplied by half multiplied by half. This, you can see half is multiplied by itself 4 times, so this is equivalent to half the power of 4. You see, negative 3 times negative 3 times negative 3, and we can see negative 3 is multiplied to itself 3 times, so this is equals to negative 3 to the power of 3. So this is example of indices. The second definition: for all a in real number and n is an integer, so n can be categorized in three types. The first one, if a to the power of n is equals to 1, so that means n is equals to 0. For this is what we learned previously, so a times a, n times, that is equals to a to the power of n. This is for n positive, and if n negative, that is equivalent to the reciprocal of a to the power of n, which is 1 over a to the power of n. Right, so for example, a, we have 7 to the power of 0, so every number power of 0 is equals to 1. Okay, so same here, 1 over 3 to the power of 0 is equals to 1. Okay, 5 to the power of negative 3, so this is equivalent to 1 over 5 to the power of 3. Okay, third definition: if a is a real number, m and n are integers for which nth root of a is real, then a to the power of m over n is equivalent to nth root of a altogether power of m, or is also equivalent to nth root of a to the power of m. So we can use these two identity to express a to the power of m over n. So for example, let's say we have 7 to the power of 3 over 2. Okay, for this expression, this is equivalent to square root of 7 power 3, or is also equivalent to square root of 7 power 3. Okay, cube root of 2 to the power of 2, this is equivalent to 2 to the power of 2 over 3, and the other way around. So we can interchange these two forms based on what we desire. Okay, c, square root of 3 to the power of 7, this is equivalent to 3 to the power of 7 over 2. Right now, so now we're going to look about the rule of indices. Okay, the first rule is if we multiply two indices with the same base, for example, a to the power of m times a to the power of n, you can see the base is the same, which is a, but have a but the power is one is power of m, another one is power of n. So if multiplied like this, we can combine them to become a to the power of m plus n, where we take the sum of the power. Okay, second rule: if a to the power of m divided by a to the power of n, this is equivalent to a to the power of m minus n. So we can see the difference. If if the index is multiplied, so we add the power. If the index is divide, so we minus the power. Okay, so third rule, a to the power of m to the power of n. So we can see it has a to the power of m is raised to the power of n again. So for this type of expression, this is equivalent to a to the power of m times n, where we multiply the power together. Okay, fourth root, ab to the power of n, and we can distribute the power to a and b. So we have a to the power of m times b to the power of n. And the fifth rules, if we have a over b to the power of n, so we can distribute the power to the numerator and to the denominator. But we have the condition here, b must not equals to 0. If not, that is undefined. So we can distribute the power, okay, for the numerator and also for the denominator. So we can use all these rules to simplify some index expression. For example, let's say we look at the first example. Without using calculator, evaluate. Okay, the first question is we want to evaluate 36 to the power of half. Alright, so power of half, okay, we can use the ratio rules. Okay, a to the power of 1 over n is equivalent to nth root of a. So here we have power of half. So that means this is equivalent to square root of 36. And we know that square root of 36 is 6. Right, so this is one way of doing this question. Right, so we also can do another way. For example, okay, 36 power of half, we know that 36 is equivalent to the 6 power of 2. Okay, 6 square. So we can change that 36 to 6 square. And now we can use the rule of indices, a to the power of n to the power of n equals to a to the power of mn. So we can multiply the power together. So 2 times half, okay, becomes 1. So 6 to the power of 1 is just 6. Right, so we have the same answer. Okay, second example. Okay, 9 to the power of negative 3 over 2. Okay, so in power negative, okay, we can use the reciprocal. So a to the power of negative n is equivalent to 1 over a to the power of n. So that means this is equals to 1 over 9 to the power of 3 over 2. And for 9 to the power of 3 over 2, we can use this rule to simplify it. So that is also equivalent to square root of 9, okay, power 3. And we know that square root of 9 is 3. So we have 1 over 3 to the power of 3. And 3 to the power of 3 is just 27. So the answer is 1 over 27. Get an example. 1 over 25 to the power of negative 3 over 2. Okay, so we can use the rule of reciprocal. 1 over a to the power of n is equivalent to a to the power of negative n. So 1 over 25 is also equivalent to 25 to the power of negative 1. And then we can use this rule. We can multiply the power together. So negative 1 times negative 3 over 2, that's become 3 over 2. So now we have 25 to the power of 3 over 2. And for the ratio power, okay, we can use this rule to simplify. So this is equivalent to square root of 25 power 3. And square root 25 is equals to 5. So we have 5 to the power of 3. 5 to the power of 3 is 125. Okay, first example. 111 over 25 to the power of negative 1 over 2. So we have we have an improper fraction here. So we change first to the its improper fraction, which is 36 over 25 to the power of negative half. And the power negative, we can take the reciprocal, but for the fraction, we just rotate, we just flip the fraction. Okay, so from 36 over 25, it's become 25 over 36 to the power of negative half. And then we can distribute the power of half to the numerator and denominator. So we get 25 to the power of half over 36 to the power of half. And the power half means square root. So that is square root of 25 over square root of 36. Square root 25 is 5 and square root 36 is 6. So this is equals to 5 over 6. Alright, so you can do this exercise, okay, for more understanding. Okay, thank you.